again. This is Einstein Helps with grade 10 mathematics. The unit is measurement, and this is lesson number 4. In this lesson we will look at the following things. First, scale diagrams. That is using scale to estimate lengths. Next, we will estimate lengths, and then we will look at measurement using first the metric system and then the imperial system. A scale diagram is proportionate. That means it has the same scale throughout the image. So we have a scale ratio, and that is the number by which we have to multiply each distance on the diagram to find what the real life distance is. We looked at various examples in earlier lessons and also in the exercises for exploration for lesson number 4. So we had the city map of Calgary. When we looked at the city map of Calgary, we noticed that for every centimeter on the map, in reality it would be 25,000 centimeters. We looked at a distance of 6.4 centimeter for one large city block, and 6.4 centimeters we calculated to be 1,600 meters. 1,600 meters is the same as 1.6 kilometer, and 1.6 kilometer is 1 mile. Then we looked at a satellite image from Google Earth of my hometown, and there we used a little ruler to find out what the distance of 1 kilometer was. And next we looked at a diagram of a human skeleton. This also was a proportionate diagram, so we could use it to compare the length of the human body with the length of the head and other body parts. Let's do one more example. And for this we go to the town of Sparwood in British Columbia. Here we have a picture of the Sparwood truck. 2 tourists have climbed into the wheel wells for size comparison. If we know or can guess how tall these people are, we could get a good idea about the size of this enormous truck. So first what we can do, we can look at the guy since he is standing up and estimate that perhaps he is 1.8 meters tall. So what we can do now is we can see how many guys on top of each other would equal to the height of the truck. Alright, so in the program GIMP, I copied the guy and pasted them on top of each other to see how many of them could stand on top of each other to equal the height of the truck. Notice that the truck is about 4 times as high as the guy is tall. In other words, if the guy is indeed 1.8 meters, the truck would be 4 times 1.8 is 7.2 meters tall. What about the length? I took the liberty to turn the guy around and to paste him in front of the truck to see how long the truck would be. And we can see it's more than 10 times the length of the guy, perhaps 10.2. So I use this in my calculations. 10.2 times 1.8 meters would be 18.4 meters. So this is an estimate for the length of the truck. A second approach could be to determine first the scale factor or conversion factor. If we measure the height of the guy in the picture, and then we compare it with his real height, or what we presume it to be, we get the scale of the whole picture. Since the guy is so close to the truck, and the truck is photographed from fairly far away, the same scale should apply to the whole picture of the truck. So I measured it, and the guy is 1.1 or maybe 1.2 centimeter tall. If in reality he is 1.8 meters tall, this would give us the conversion or scale factor that in reality everything is 150 times as long as is shown on the picture. Or If we go from centimeters to meters, the conversion factor would be 1.5. Notice it's 150 divided by 100. So if the truck height in the photo shows to be 4.5 centimeters, then the real truck height would be 1.5 times 4.5 is 6 meters and 75 centimeters. And the length of the truck, if I measure it in the picture, it is about 12.1 centimeters. So I do 1.5 times 12.1 is 18.15 meters. 18.15 meters long. Now we will look at estimating lengths in the real world. We already learned several things because we can use proxy units. We can use certain body parts or other objects for which we know the length. Like the width of a nail on my little finger is about 1 centimeter. My hand, that is 4 fingers beside each other, the width of my hand is about 10 centimeters. And the width of a man's thumb just below the nail is about 1 inch. So these are some of the proxy units that we can use to estimate the size of real life objects. I will show you 2 examples from my curiosity cabinet. First is a mammoth molar. Yes, that's the molar or tooth that is found in the mouth of a prehistoric animal called the mammoth. I have a sample of this that fishermen found at the bottom of the North Sea. All right, here I'm holding it up, and you can see that in the photo there's a picture of my hand. So now look at the width of my hand and try to estimate how many hand widths it would take to cover the length of the mammoth molar. Try to do this carefully, and you should get a length of about 2.5 hand widths, which means it's about 25 centimeters. And in fact, that is fairly accurate. Here's a second example. This is a raccoon skull. All right, if you just look at the skull, it's pretty hard to guess how big it would be. So for comparison, I'm adding my thumb, and my thumb is right on top of the skull. If it was any closer or farther away, it would no longer work for size comparison, because my thumb would look bigger when it's closer by and would look smaller when it's farther away. So in this picture, you will see the size of my thumb, and if you have a thumb width, you remember that is 1 inch. So if you look carefully, you can guess the length of the skull. In fact, the skull is about 5 times the length of a thumb, so that means it's about 5 inches, or about 12.5 centimeters. Here now is a picture of part of a ruler. This is the question. Is it a metric ruler or is it an imperial ruler? Notice the subdivisions. There are 10 subdivisions, 5 and 5. So the unit is divided in 2 and furthermore divided into 10. This is typical for a metric ruler. Remember, if the whole unit here is 1 meter, then each little part, or 1/10, would be a decimeter. If the whole unit is 1 decimeter, then 1/10 of it, every little part, will be 1 centimeter. And if the whole unit shows 1 centimeter, then every little part would be exactly 1 millimeter. Here is one of my Sharpie markers. What is the length of this Sharpie marker? If I put the ruler beside it, and I put the 0 exactly at the end of the marker, then the other end is close to 13.5 centimeters. So it's roughly 13.5 centimeters. But if I look closer, I notice it's a bit shorter. So let's say it's 13.4 centimeters or 134 millimeters. Here I have a lens cap for my camera. What is the diameter of the lens cap? It's between 5.5 and 6 centimeters. So if I look very closely, I would estimate it to be 5.9 centimeters or 59 millimeters. All right, now to imperial length measurement. When we measure how tall a person is, we use feet and inches. If we measure shorter lengths, we use inches and parts of inches. So, although metric rulers use decimal numbers like 3.6 meters or 12.4 centimeters, imperial rulers use fractions. You discover this when you buy wrenches. Metric wrenches use millimeters, but imperial wrenches use fractions like half an inch, a quarter inch, 1/8 inch, etc. This is the typical layout of an imperial ruler. 1 inch is divided into 2 halves, each half into quarters, each quarter into eighths, and each eighth into sixteenths. Of course, they simplify the fractions. So if you follow the ruler in sixteenths, you get these fractions. 0 inch, 1/16, not 2/16, but 1/8, 3/16, not 4/16, but 1/4, 5/16, 3/8, 7/16, half an inch, 9/16, 5/8 of an inch, 11/16 of an inch, 3/4 of an inch, 13/16 of an inch, 7/8 of an inch, 15/16 of an inch, and 1 full inch. Finally, we will do some measurements in the imperial system. I have 2 objects. The first one is a CD case. So I measure in the horizontal direction, and I see it is about 5.5 inch. Now it's actually a little bit more, and so I would add 1/16 of an inch. That's one little subdivision on this ruler. So 5.5 is 5/8/16. Add 1/16. That gives me a total of 5/9/16 inch. In the vertical direction, I see it's almost 5 inch, but it's actually 1/16 or perhaps 2/16 inch short. So that means it would be 4/15/16 or 4/14/16. In the middle, that would be the best. So what is the middle between 4/15/16 and 4/7/8? Well, 4/15/16 is 4/30/32, and 4/7/8 equals 4/28/32. So the middle would be 4/29/32. Now let's take a look at the DVD case. The length is about 7.5 inch. Oops, it looks like it's a tad smaller. I would guess about a half of 1/16 inch on the left and half of 1/16 inch at the right. So together it should be 1/16 inch shorter. That would be closer. So 7.5 inch is 7/8/16 of an inch. Take away 1/16. So the most accurate result I can come up with is 7/7/16 of an inch. That was the length. What is the width of the DVD case? It's about 5.25 inch. I would say a bit more. Let's add 1/16. 5.25 inch is 5/4/16. Add 1/16 and I get 5/5/16 of an inch. Well, this was the last instructional video about the measurement of length. The following lessons we will go into two-dimensional space. So it's not just length, but we're talking about length in different directions, and we're talking about the sizes of angles. So we will have an introduction into trigonometry. Trigonometry means it's a measurement of triangles or angles in triangles. First, finish the exercises to review the information to see if you understand everything. Try some of the challenging questions for ongoing exploration, and then review the 4 lessons so that you are prepared to write the assessments for the first part of the measurement unit. And then we will continue, and it will get more challenging but also more interesting. We love math, don't we? See you next time.